My dear friends, welcome back to Bee Spice. This is Bala with you. In this session, we'll focus on-off valve design and specification, wherein we'll focus on the valve design in this session. Okay, so this is the look and feel of the on-off valve. As you can see here, this is your valve body. This is your solenoid. This is your actuator. This is your feedback. And this is your air pressure regulator. So this is the look and feel. In fact, many of our friends, viewers, members, they actually asked for this. That is why actually I started uploading this on-off one. And the next session will also focus on the actuator design. And also we will focus on the emergency shutdown valve, ESD bar. Okay, friends. So this focus is more on-off valve. Okay. So first we'll talk about the valve type selection. Okay. So here on-off valve shall always be line size valves, meaning whatever is your line size, so the same size, the valve will also be there. 2 inch means 2 inch, 4 inch means 4 inch. Okay. So that is a point. Okay. Generally up to and including 4 inch. Okay. So the ball valves, it's either reduced bore or full bore. That is the concept, friends. So you may have a question here. What is this reduced bore and full bore? Yeah, you see here, this is your full bore. As you can see here, it's almost same, right? Same as the pipe, right? Yeah, say full bore. Then here, pipe is here, right? But you have some, reduction here. So that is the reduced bore. So, by looking at it, you can tell like that. But, there is also, some aspects behind it. Friends, this full bore actually, valve opens completely, okay, creating an unobstructed path for gases or liquid through a tube or pipe. Okay, that is one point. So the valve size is equal to or larger than the internal dimension of the bore of the end connection. So that is the point. That is full bore. The valve size is equal to the internal dimensions of the bore of the end connections. Okay. So full bore valve are commonly used for transporting viscous materials along the pipeline due to their low fluid resistance. So that is the point, friends. And of course, these are all available in various pressure classes, like, typically ranging from 150 to 2,500 pounds rating. Okay. So coming back to the reduced bore, this actually, friends, the opening of this valve is smaller than the end connection internal diameter. That's it. So here you see the end connection here. So it's a smaller. So that is the point. Typically, this is used for smaller pipe feeding material into tanks, or storage units, and typically in refineries. So reduced bore have a smaller volume, making them to easier to install. So their internal parts are wider for flow actually compared to the path diameter. The internal parts are wider for flow. Okay. So in summary, if you narrate this actually, full bore valves are larger. Full bore larger, provide unobstructed flow. While reduced bore are smaller and of course more space efficient for specific application. So that is the point, friends. I hope with this understanding, we can move on further. Yeah. So ball valves larger than 2 inch shall be Trunnion mounted. Trunnion mounted. So Trunnion is nothing but, is a quarter turn valve actually used to stop the flow of medium in the pipes. Basically, these valves actually feature a round or a spherical disc. As you can see here, this one, Trunnion, right? Yes. Round or a spherical disc in the center that rotates to start or stop the flow. Okay, that is the point, friends. So the disc is called a ball and it features a hollow center actually. You can have a hollow center. So trinity mounted valves feature, additional support for the valve. Okay. So this support is in the shape of a shaft. You can see here. You see here the shape of a shaft. Okay. And this is called a true union. Okay. True union. Okay. So this true union absorbs any added pressure from the flow and it reduces the stresses on the ball. That is the point and seats of the valve. So this Trinunion mounted ball valves are used in high pressure, large scale application where low operating torque is required. Okay. So that is the point. Okay. So anything? So to sum up, friends, Trinunion mounted ball valve has a similar structure as traditional ball valve. There is no doubt. But the only difference is Trinunion ball valve or have an additional mechanical anchoring. This is what that supports the ball or disc. Okay, right. So that is the in this design the ball is supported from both the ends. You can see here. Yes, this is the one. So on x-axis so that it stays in place and easy to control. Okay, so that is the beauty of this Trinunion. I hope this is also clear, right? Okay, friends. So now for larger sizes, double flanged triple eccentric butterfly balls are selected. When full bore is demanded, then ball valve shall be used. For if it is a larger, meaning more than 4 inch, double flange triple eccentric butterfly valve shall be selected. Except when full bore is demanded or needed, then we can go for a ball valve. Okay, so that is the point. So the triple eccentric, all this we have in fact covered in our valve types. If you have time, you can watch it. In fact, it's uploaded free actually, not a member one. Okay, you can watch it. In steam service, the ball valve shall be used irrespective of the pipe diameter. Okay, friends. So in steam service, ball valves shall be used irrespective of the pipe diameter. Just remember that all pressure contained parts of the valve shall comply with the material specification. So that is the point. Always remember, all pressure contained parts of the valve shall comply with the material requirement of the specification for piping. Okay, right. For example, for sour and wet hydrogen service, H2S, hydrogen sulfide service, all the pressure retaining parts shall be of the material suitable for the process application and in compliant to NACE MR 0103, National Association for Corrosion Engineers. Okay, friends? I hope this valve selection is clear, right? Okay, good to go. Now, in the valve selection, few more aspects actually. Valve body thickness shall be as per ASME B 16.34. I hope you know this, right? Yes. So here I'm talking about the body thickness. Additional margin for corrosion allowance shall be considered as per relevant pipe class or in line with the instrument data sheet. Okay. See, of course, the valve body thickness shall be in line with ASME B 16.34. But additional margin for corrosion allowance also should be considered. Okay. Then another point, the body pressure rating should conform to the relevant piping material specification. So everywhere, friends, the piping material specification matters. Okay. So the ball valve shall be designed to provide body cavity pressure relief construction. As you can see here, you have this relief groove, right? Yes, you have a relief groove, right? Yes. So this is in full closed position. This is a full open position. So the point is the ball valve shall be designed to provide body cavity relief, pressure relief construction. So this also you need to watch out. Okay. So this is about the valve type selection. Okay. Now we go to the trim type selection. What is trim basically? Stem, seat, and this, bar, right? Yes, these are the three stem. Okay. So if you see here, friends, special attention shall be paid to the design of high depressurizing valve with respect to noise and severe process condition. This is obvious, right? Always we should we should have a special attention for a high rate depressurizing valves. Okay. Generally, these kind of valves, shall be sized for the flow rate specified to avoid the overload of the flare system. That is a point. So we need to size this valve for the flow rate. That's what we do actually. Yeah. So the valve trim shall be generally of type 416 or 316 SS. So that is the point. This one, all this should be 316 or 416 SS. So this is how we select the trim type. Okay, friends. So I hope this is also clear, right? Okay. Now, valve end connection. I'll talk about the valve end connection, meaning the flange. The flange. Okay. On-off valve shall have flange connection which conform to ANSI ASME B16.34. I hope you know this, right? We have talked about this numerous times actually in our videos. Okay, during the data sheet preparation, all these. Right. So on-off valve shall have a flange connection conform to ANSI ASME B16.34. Welding or wafer, wafer in the sense the body clamp between the pipe flanges, this type should be avoided. Should be avoided. We should have this flange connection, not like a wafer connection. Okay, friends. So that is a point. So flange rating shall comply with specification of the piping material. This flange rating. If it is 150 with the pipe, then 150. If it is pipe is 300 rating, then you have to go for 300. That is the point. And flange face finish shall be in accordance with ASME B16.5, para 6.4.3 or B16.47, para 6.1.4.2. Okay. So this also we have seen many times. Yeah, I hope you know this, right? Yes, flange finish. Here, flange connection ASME B16.34. Here, it's a flange face finish. Okay, B16.5. Then we have a roughness, the resultant phase. That is the roughness average between 3.2 and 6.3 micrometer. Alternatively, we call it as 125 micro inch to 250 micro inch. And this is also we need to watch out for. Okay, friends. So this is about the valve end connection. Now we talk about the bonnet, friends. You see here. You see here. This is a bonnet. Yeah, this is the bonnet. Okay, this is a bonnet. And here also you can see here the 11. Yes, this is the bonnet. Yeah, you can see here, this is your bonnet. Okay. So maybe you may ask a question, why this is like this? Yeah, the bonnet is the extended bonnet. This is the extended bonnet. I just want to show you. Okay. So that's it. Yeah. Now we will see. Yeah. We'll see the bonnet types. Yeah. Bonnet actually assembly shall be of same material as the body and of the integral or bolted type construction. Okay. So that is there. See, basically like this will be integral or bolted like this. Bolted we can always take out. That is the point. Okay, friends, right? So threaded bonnets are not acceptable. This cannot be threaded. Can be bolted but not threaded. That is the point. Stuffing boxes shall be bolted gland type. So the stuffing boxes shall be bolted gland type. You see here the packing. You can see here packing. 10, right? Item 10. Yeah, here the stuffing boxes shall be of the bolted gland type. Yeah. Extension bonnet shall be provided where the operating temperature is outside the range of 0 to 230 degrees centigrade. Okay. So if it is, more than this, then you have to go for this kind of extended bonnet. Okay. So bonnet with environmental seal, basically we call it as a live loaded packing shall be provided for toxic service, live loaded packing. Okay. So that is also you need to have it. Okay, friends, we will see here. Yeah. So, yes. One moment. Yes. Yeah. So probably I think you may have a question, right? What is this live load packing? Yeah. See, friends, live load packing actually provides constant compression over time, particularly important in certain types of service such as high pressure steam. Okay. Once the steam begins to leak, through the packing, you see, this is your packing, right? Yeah. If once the steam releases through the packing, actually, it establishes a flow channel that can only be closed by tightening the packing so that to such a degree that valve stem cannot move actually. Once the stem begins to leak through packing, is establish a flow channel that can only be closed by tightening the packing to such a degree that valve stem cannot move. So here valve live loading is a technique actually to maintain the consistent packing stress in the on-off valves. See, Why actually we need a valve packing? Valve packing ensures a tight seal, right friends? Okay. So live loading prevents leaks by maintaining proper packing stress even during valve operation. So that is the point of a live loading. Okay. So how this mechanism here actually? There is a bevel, you can see here, this one, number 10, you can see here. Yeah, you have this, bevel spring washers. It's placed between the gland follower and the Forstner actually. Okay. These springs actually exert a continuous pressure on the packing material. So as the packing volume changes, due to whether wear or adjustment, the spring compensate, keeping the packing stress optimal. So thereby it prevents the leak and ensures effective sealing. So that is the point. Okay. So where we can use this, basically suitable for frequently cycled valves, very frequent operations, and under high pressure and temperature. Okay. So this is the point. Okay. To sum up, unlike standard solution, line load packing actually provides a constant compression over time, particularly important in certain types of service such as high pressure steam. Once the stem begins to leak through packing, it establishes a flow channel that can only be closed by tightening the packing to such a degree that valve stem cannot move. Okay, so that is the point actually. Okay, I don't know whether you got it. So basically, live loading is a technique to maintain a consistent packing stress in on-off valves, friends. That is the point actually. It ensures the tight seal actually. Right. Live loading prevent leaks by maintaining proper packing stress. That is the point. Okay. So I hope you got some idea on this also. Now we go into the face-to-face dimension. Face-to-face dimensions themselves conform to ASME B16.10 or APA 609. So where the size and type are covered by the standard, right? Always remember face-to-face dimension. This one, friends. This one, face-to-face. So B16.10, API 609. Okay. So that is a point. Then we have a valve seat leakage. Friends, seat leakage classes for each valve shall be defined in accordance with the ANSI FCI 70.2. That one you remember, seat leakage class. Generally, leakage class for two-way on-off valve shall be class 5, minimum, okay, two-way on-off valve, and class 6 maximum for a flare application, okay. So class 3 shall be applied for three-way on-off valve, okay. So valve sheet leakage shall be specified on the instrument specification data sheet, of course, and in case of tight shutoff, if TSO is specified on the P&ID or process instrument, then leakage class shall be 5. Tight shutoff means 5. Only valves venting to flare application have a class 6. That is a point. So for ball and butterfly valve, the leakage test shall be performed as per ANSI FCA 70.2. So if you see here this leakage class, you see friends, this is your leakage class. This is a maximum leakage. This is your test medium, pressure and temperature. You see here, class 2, 0.5% of the valve capacity at full travel. Class 3, 0.1% of valve capacity at full travel. Class 4, 0.01 valve capacity at full travel. The medium is water or air. And the service is like, 50 psid, whichever is lower at 10 to 52 degrees centigrade. Okay. When it comes to class 4, yeah, that is 0.01. Oh, when it comes to class 5, you see 0.0005 milliliter per minute per PSD per inch port dia. See how much, tight shutoff, right? Yes. So this is for water and service DP at 10 to 50 degrees. Okay. Then for class 6, even more stringent. You see the port dia. For one port dia, minimum bubbles per minute is only one bubble. Just imagine, milliliter per minute is 0.15 only. Then if it is 1.5 inch port dia, it's a 2 bubbles. If it is 2-inch port dia, 3 bubbles. 2.5-inch port dia, 4 bubbles. 3-inch port dia, 6 bubbles. 4 port dia, 11 bubbles. 6 port dia, 6 inch. Okay. Yeah. This is 27. Okay. So likewise, you have this leakage class. This is about the leakage class. Now we'll talk about the gland packing. So yeah, because I covered there, but I want to give you a detail because I'm not sure whether the explanation is good. See, there is, gland packing protection. Okay. So gland packing protection shall be provided to prevent damage from entrance of the wind blow sand. You see here, friends, this is your stem, this is your ball. You see here, this is the gland packing and gland packing. Okay. So yeah, yeah, yes. So you may ask actually, what is this wind blow sand, right? Okay. Wind blows sand in a on-off valve, okay, gland packing protection refers to the phenomenon where sand or other fine particles are blown by wind and can infiltrate the packing area of the valve. So it can infiltrate the packing area of the valve. Okay. So this can lead to what? Increased friction, reduced sealing effectiveness, and potential leakage around the stem. Okay, right? Right. So proper gland packing design and maintenance are essential to prevent windblow sand from compromising the valve performance. So that is the point, friends. If you remember previously, we talked about the live loading, right? So the live loading enhances sealing performance and reduces the risk of leaks actually. So this guy on top of it, it's actually a protection. Yeah, that is a point. Right. I hope now it's clear, right? So now I just want to give you a bit. You see here, you have this ring, right? Yeah, this is the one. Packing supporting ring. You see here? Yeah, this is the one. Packing inside. See, this is a live loaded packing. You can see here? Yes, that is what. Right, friends. Okay. There is also some other criteria. I will talk about that. The protection shall be removable without disconnecting the actuator, yoke, boss, or stem connector so that the gland packing nut tightness may be checked and without disassembling the valve actuator assembly. So that one should be removable. Okay. Then gland lubricator shall be provided. And the main point note is no asbestos, the gasket packing. So for PTFE, we can, up to 200 degree we can use. And graphite, actually, you see, the graphite packing, we can go up to 400 degree. And metallic piston ring for high temperature application. So this is about the gland packing, friends. Okay. Now I go to the cryogenic service. Okay. See, you can see here, friends, extended bonnet, right? Yes, this is the extended bonnet. So this is purely for the cryogenic service. So cryogenic service extension bonnet shall be used and the length of the extension shall correspond to the service temperature and insulation requirement. That's it, friends. I hope you got some insights. So just to recap, actually, just to recap, we talked about the valve selection, type selection, like full bore, reduced bore, trunnion mounted valve. Okay. Then we also talk about the trim selection, like SSL 416316, right? And we also talked about, valve end connection, which is, in line with the ANSI, ASME B16.34, and also the flange face finish, in line with ASME B16.5, and also the face thickness, a roughness aberration, 3.2 and 6.3, right? Valve end connection. Then we also talked about the bonnets, okay? Extended bonnet for more than temperature 0 to, outside the temperature of 230 degree. That is for extension bonnet, okay? And we also talked about the live loading actually. So live loading, what it does, it enhances the sealing performance and reduces the risk of the leaks. Okay, so that's a point. And also we talked about the face-to-face dimension. So that is in line with ANSI B 16.10 API 609. Okay, and also we talked about the leakage class, class 3, class 4, class 5. Class 5 means tight shut off, right? Class 6 means it's a very stringent and used for the flare application. Yes. Then gland packing also we talked about. And yeah, for PTFP, no asbestos should be used. Okay. And for 200 degree up to, we can go for Teflon. And more than that, up to 400, we can go for graphite seal. And if it is more than that high temperature, we can go for metallic piston ring. And cryogenic service, you use the extension bonnet. That's it, friends. Any feedback, you can write to us. And next video, we'll talk about actuator. Okay. Thank you. Not only I'm not going to stop here, I'm also going to talk about the, ESD valves also. Okay. Thank you. Take care. Bye-bye.